Thanks. I wanted to focus a little bit on these business consumer apps that we build. Hence, really is the productinfinia.com is the domain, and I just will go over briefly what I wanted to cover in this talk and stress the importance of Asterisk in the midst of all this functionality. So, what we do is we provide uh, voice input and voice output for productivity applications. Specifically, we read out Gmail, Yahoo Mail, and you can make PayPal payments all from any phone, not just smartphones. We also have smartphone clients, but our focus is speech in, speech out. And I'll go over a few of the technical details of our architecture, but the focus is on a couple of problems that we hit that we thought pretty much if you're scaling any application, you will have to solve them. And that's using Opensips for load balancing, which on paper with the tutorial appears simple, but we hit a couple of problems, and I have the exact code in my presentation to fix the load balancing problems. Async AGI also we had, I mean on paper it looks really simple, but there are a couple of synchronization issues, and I'll explain what it is and give you the solution. And something that Asterisk developers don't talk about too much is we are fully deployed in Amazon, and we have local server deployments too. So I'll talk a little bit about the challenges with Amazon. So what is hands freely? So our goal is to provide enough services so that we can charge you for it. And the charging itself, we stuck to PayPal. They're incredibly easy to work with. We are based in Silicon Valley. We meet product managers from PayPal all the time, and I'll explain what the adaptive API is and why we think it fits in very well with mobile solutions. In fact, today is, I think, the last day of the PayPalX.com conference, and they wanted me to speak out there, but I told them about Astricon, and they were excited about it. But you should work with PayPal if you get a chance. But what we do is we read out Gmails and Yahoo Mails, and not only can you read out, you can also compose, you can choose a name from your contacts list. The contacts themselves can come from Facebook or LinkedIn. So we have all these integrations with various web services, and how we do it very briefly. I won't go into too much of the details with the Sphinx recognition system. If you're using Nuance or Vlingo or even the Gmail transcriber, the Google transcriber on Android, you have a couple of alternatives, but we chose our homegrown solution. Cepstral for text-to-speech works just great on Linux. And our focus has always been on recognizing names and contacts. It's not on speech recognition or for transcription. Google offers that on the Android through a very simple API, and we don't want to invent what Nuance and Vlingo is doing, and is doing pretty decently. But the key thing is deployment wise, we are fully available as an AMI on Amazon, and I'll explain what that is. And it has tremendous benefits, especially if you are talking about a global deployment like we are. I mean, we are going to roll out in Asia and in Europe. The US is a very different market for us. So we needed a platform that can scale globally, and that's where Amazon fits in very well. So how we support our web services, primarily we have a PSTN gateway, and if you attended the Harriet case study in the morning, you would have noticed all the problems they dealt with when dealing with carriers. We just didn't want to deal with it. Our stack without the PSTN problems is very deep and complex. So we outsource that to junction networks. It adds a little bit of latency to our calls, but it removes a very big headache for us. The PSTN gateway talks to Asterisk, of course, and it's deployed on a bunch of low cost hardware. And it talks to a custom Java engine. And the key thing is we go out to a bunch of web services. And you can do anything from, go to any website. We can read out any website to you. But our forte is not reading out any content on the web. It's accessing secure content. And by secure, I mean what's in your email box, Yahoo Mail and Gmail, using a very specific protocol called OAuth for security, and I'll talk a little bit about it later on. And we're also integrating with Facebook, which through their API is not really a big deal. Just to clarify what I mean by load balancing problems using Asterisk. So what we have is we have our PSTN gateway. In our case, is Junction Networks. It's all web-based, very easy to administer and set up. Literally takes about, a couple of minutes and to set up on the web. And then we have our farm of low-cost servers. And these servers can be on Amazon, and they can be, you can vary the number of instances and where the instances are located, all programmatically. So it's a very powerful system that Amazon provides, which we leverage. And we can also deploy locally. So we have our own bunch of local servers. So for some workloads, we have local deployments, and for some, we have Amazon. But what we are trying to do is in between, we have basically the SIP protocol, and it's got to be load balanced. We are totally stateless in the back end. That was a very big design decision. And whatever state we want to carry, like for instance, when we are reading out your emails, when you are at a particular email and your next response is to compose a reply to the sender, there is state, but we try to keep that. I mean, we don't introduce it into the SIP dialog. So the client can be any dumb phone, which is not SIP aware. So that was a very big design decision. But what we were trying to do with OpenSip was, so we've got this farm of servers, and we have got these SIP requests. And what OpenSip, at this link that I have up there, they have a tutorial on load balancing, which, by the way, is extremely simple. You set up a MySQL or Oracle database, and you just mention what kind of servers can handle what type of workload. So you can have a pool of servers dedicated to transcoding, a pool of servers dedicated to voicemail only, and you can have multiple pools of servers and populate a table with the IP addresses of the servers. And the load balancer, I'll show you the script, basically in one method invocation can pick one of the servers depending on the workload request you submit. And you can pick one of the servers and transmit your SIP request to that server. The problem, what happens is what the OpenSip is trying to do is it's trying to only load balance invite requests. And the goal is once your invites are load balanced, the server communicates with your junction or your PSTN gateway directly and avoids the load balancer. So the goal is for invites to be load balanced, and all the other requests, including buy, they basically bypass the load balancer. So RTP goes directly from source to our server and doesn't go through the load balancer. And if you have ever looked at OpenSip's code, it's really ugly C code, extremely difficult to understand, but you can do in a couple of lines of code what would take us, I mean, it would take us weeks to write a load balancer. You can literally do it in one line, and that one line is load balance. And you ask for the number of instances, and you ask for the type of resource. Those are the two parameters. So you can have a resource dedicated to transcoding or just PSTN gateway or voicemail. So that's what you're trying to do, and you're only load balancing invites. And if you ever looked at Opensips code, how you focus, don't ask me what that is, but what you're trying to do is you're going to only look at invites. And what the trick you're playing is, when you get an invite into the OpenSIP load balancer, you're not going to record the route in the SIP header. And when the packet reaches the destination server, it's not even aware of the load balancer, so it responds to the originator of the SIP packet. So that's that one line of code that basically gets rid of the load balancer from the SIP communication. But the problem is, if you leave out the load balancer from the SIP header, when the session is done and you have a buy request, the load balancer will not be informed about it. So in essence, the load balancer assumes you have, suppose you direct 1,000 sessions to a particular server, it doesn't know those 1,000 sessions have ended. So that's one problem you've got to be aware of when you're using Opensips for load balancing. The other alternative is to load balance all requests, but you'll add the load balancing latency to the request. So it was a trade-off for us. So to set up the stage for the next problem, which is, why we use Async AGI extensively. I mean, the motivation was, we have all these web services that we support. Couple of them, especially the PayPal ones, they are pretty intensive in terms of the latencies they take, either to our servers or to PayPal servers. And the key reason is security. All the traffic is to our site and to PayPal site. When it is money related, it is HTTPS. And with SIP and HTTP, you have this huge security hole that the other speakers and the other sessions were talking about. But it's a huge problem, especially when you're dealing with money. So the bottom line is, when you're using any API that's secure, you have these huge high latency operations, and we want to be asynchronous as much as possible to make the user feel like there is some activity happening. So I'll go briefly over what the PayPal adaptive API is, and then I'll explain the Asterisk part of the problem. PayPal has a bunch of APIs, and what they're trying to do is, if you noticed eBay's revenues for the last quarter, PayPal clocked in at about $1 billion. And what they're trying to do is, they're trying desperately to become the payment gateway on all mobile platforms. And if you really talk to PayPal, when they say mobile, they're really not talking about voice calls. They're talking about Android and the iPhone. And they're also talking global. So they have various market segments thereafter. We're obviously interested in, being the Asterisk voice enabler for PayPal applications. And with adaptive APIs, what you get out of all their APIs is, basically the user pre-approves our website and the user's phone for a particular amount. So there is an API, and you go to our website and you're transferred to PayPal, you're redirected to PayPal, and in PayPal you authorize Infineer.com to make payments up to a certain amount, and you also enter a PIN that you use later on to authorize payments. So now, after you've done the pre-approval, whenever you call Infineer.com, you're basically, with the PIN that you give us, you're authorizing us to make payment